Huh?
No, we can. I'm
All
just
right. Cool.
looking for. Yeah,
Okay.
there
So
you are.
go
I
through
wanted
this.
to find those questions.
Let me send you the question that you're gonna start with, right?
Okay.
Okay. Let's start with this one right here. That one
Yeah,
right
that
here.
one for the second derivative. Yeah, we need to do it again because.
No problem. No problem. And that one. So I'm gonna send you the question which you're gonna start with, right?
Okay.
And then this one right here. All right. So I think we have some question right here. So we can start with those one. Okay. Okay. Let's start with the first question. The first question.
Are we starting with the one of the second derivative?
Let's start with the one of the 12e. So they give us f of x equal to 12x e 6x. So this is very easy because, excuse me, 6x. You know why it's very easy? Because you have a two function. What is the first function? X,
Of
the second function,
x.
e, power sum. So we know this is a product rule. So for product rule, oh, let me put more closer. Maybe I should just put more closer.
Is it 6?
Eh?
Is it E6x?
Yeah, 12x e6x. Should I write big a little bit so you can see?
No, it's okay now. It's fine.
All right, if you cannot see, let me know. 6x. Let me write more bigger so you can see better. 12x e6x. Like that. Okay, so what I'm gonna do, let's say differentiate. We know this is gonna be product rule because I got x and e6x. This is just a number. So I'm gonna say first, if there's a product rule, then I know even a product rule is gonna be f of x prime because everything here is x is just x. There's nothing like changing to the power or change to the root, no. So I'm gonna say f x prime means we can differentiate equal to the second one, we're gonna write to the constant, which is, oh, okay, or you can say, look like this. 12 is just like 12. And then we'll deal with this function because 12 is just a constant number. Has nothing to do with this. You understand? So
Okay.
write up
Yeah.
12, and then I'll deal with this. So this is going to be constant, the second one, and then I'm going to differentiate x. Differentiate x. And then I'll plus, now the x is going to be constant, and then I'll differentiate e of e 6x. Do you understand it? Oh my God, let me do this.
Yeah.
Should I again, or you understand?
I'm good.
All right, cool. So now this going to be f prime equal to 12 is just a 12, and then I will come here. E6x, E6x. When you differentiate x, what do you have? What do you get? What do you get?
1.
1. So it's going to be 1. Now plus with plus. X is just x. When you differentiate E6x, what do we have or what do we get?
Hold on, sorry. Plus x.
Exponential.
Okay, I think I'm thinking too much.
No problem, no problem. Look. So whenever I have an e with the power, we differentiate the power, we get the number. Always the exponential differentiate to get the number right behind. Do you remember that? Look, if somebody give you,
Oh, yes, you write the 6 behind, right?
so we're gonna say 6 behind. So let's write our bracket here. Let's say 6 must be behind.
Okay.
And then
And then I can't believe this.
No problem, no problem. We all forgot. So we write.
I actually forgot this part. Wait.
We write exactly e power something. If somebody give you e
What's happening with my brain?
square, differentiate. What you do, you differentiate whatever is on top here. Look here. It's going to give us 2x. We
Okay.
e here. It's going to give us what? 2x. And then you write exactly what you have here.
Oh, okay. I think I was confusing because the 6 is before the x. It's not like when it's x6. Because then it's a little different. So it is just 6 on its own. Then you write e to the power 6a.
And then we write exactly what you have here.
Yes, yes, yes.
So this is going to give us e6x. And then,
So, Hamish, can I just ask, so if it was, let's say e to the power x to the power 6,
okay.
then it would be 6.
So say e to the power x to the power 6. Okay.
So it would be
equal to?
It would be 6x to the power 5, correct?
To the power 5, yes. And then?
Okay. Oh, yeah. Okay. No, I understand. I wanted to make sense of something in my head. Yeah.
And then?
It's okay.
So this is not finished yet.
And then it's going, yeah, then it's going to be ex to the power 6.
E x power 6. Yes. Very good. So will I be clear? Will I be saying?
Yeah, it's clear now.
So we're gonna say, okay, 12 is just a 12 outside. Make sure you pay attention to your bracket, right? You don't mix up.
Okay.
So this is gonna be equal. 12 is 12. Bracket. Now, I think I'll take 6 out here. Like 6 is going to be behind the number.
Oh, you want to take it out?
Yeah, just behind here, you know?
Oh, yeah, yes.
Or if you don't want to do that, you can just say, look, this and this is common, so I can take it out. So I'm going to say, in this group and that one, I'll take E6X, and then write my little bracket here. I'm going to be left with 1, and then plus 6 and X.
6x.
And this is going to be X prime.
Okay.
Okay, say it again. You want me to say it again?
Hold on.
All right, no problem.
So,
okay.
So how can you tell that the 12 was not part of the equation? Like what? Like would we have gotten the same answer if we had said 12x?
We can do that. We're going to get the same answer because look, your function is x and e6x. This is just a number, of constant, so I can leave it out.
Okay.
Now let's.
So even if we had said 12x, we were going to have the same answer.
Same answer. Let's do the 12x. Let's do the 12x. Let's do it.
Okay. Because that's what I wanted to understand.
Okay, no problem. And thank you for asking. You're the only one now who attending the classes. Most of the people don't attend.
And we have an exam. Now I don't wanna like go through a lot. Like
It's only
I'm
you.
not trying like yeah.
Let me listen. I'm listening. What is that? You don't want to be under pressure.
I'm saying especially because I saw the date. Maybe they haven't seen the date yet of when we are writing, you know.
Yeah.
Because no, I don't wanna I don't wanna panic.
It's gonna be too much.
I really don't wanna panic.
All right, let's go. So now you say you want to take as a 12 at e power x. So we're gonna say all right. So this is gonna be f prime. So now this is product rule. So the second one we can put it constant.
Yes.
And we differentiate The first one. What is the first
The
one?
first one, yes.
12x. And then we're going to plus. Now 12x is going to be constant.
Yes, 12x.
And then we're going to differentiate
Mm-hmm.
the e.
Yes.
Now we go. So then we say here, well, this is e6x. Here, when I differentiate 12x,
Yes.
go ahead.
12.
12. So on the left is 12. Plus and plus. We have a 12x, we have a 12x. I'm going to put my little bracket. When you differentiate e6x, what do we get?
We get 6e6x.
6e. I think this is, actually this is way more easy, I think. Okay. So we will say prime. Remember now we differentiate the prime. Okay, what is the common for both? 12 and 12 and e6x, e6x is common for both sides.
Yes.
So I'm going to write my 12 out and then e6x because it's common here and there and 12 and 12. And then I'll write my bracket and then I will leave it here. There's nothing. What I'm going to be left with? 1.
1.
And then we plus. What is going to be left this side? If you take out 12 e6x here out, 12 and e6x, what is going to be left on the right hand side?
6x.
Eh?
6x.
6x. All right.
Because the 12 is going to be divided, then you're going to be left with x, and then you remove that e6x, you're left with 6 or 6x. Okay.
Very easy. We're done with that. So
Okay.
Go for it. Now let's finish up this step. Okay, so now the next one. Let me do the last question, the one I sent you. F of x equals 14. F of x.
Okay.
Equal to 14. Plus plus. Long. Bracket x. Product of x plus 5. All right, so what we're going to do here, very easy.
Yeah. Okay.
No, it's very easy, this one. Look, because very easy, kid. I'm gonna make it easy for you.
We'll see if it's easy.
It's easy, I promise. So what we're gonna do first, we're gonna say differentiate. We're gonna differentiate everything, okay? But this one here, this is a quotient.
Yes.
Look what I'm gonna. I'll say this. Look, a prime equal to, we differentiate here d, the x of 14, which you know is gonna be. When you differentiate 14, what you're gonna get?
0.
0. Okay. So now you come here and say differentiate all of this stuff. None of a function. What is a function? X plus 5. So this is going to be 0. So let me say 0 plus, so I don't have to write my 0. I can simply say I have to deal with this. But when you differentiate none of a function, when you differentiate none of, okay. What about the none of a function? What do we say? If you can remember. None of a function.
We differentiate is it the variable?
The function?
The equation. So we differentiate the equation and then we divide it by how it is.
The function, we call it function. The
Function, yes.
So this is going to be f prime of x over f of x.
Yes.
So the same thing here. So what is the function? This is a function here. So we're going to say differentiate your function What is the function? X plus 5. And then we over exactly what we have, which is x plus 5. That's all. Means.
Okay.
Okay.
Can I ask a question?
Please ask me.
So when you differentiate
Yes.
along that is a coefficient, does it mean you're going to divide first in the insides, then divide the entire thing?
Okay, look, listen. Listen, right? According to the rule, right? Anything which is in front of the long, you differentiate to right and top.
Yes.
And then we divide exactly what we have here at the bottom. This is function. What is a function? This is a function here.
Okay.
So I'm going to differentiate my function. Don't look how it looks like. What is my function? Is x square root of, like all of this is the function. We differentiate that.
Okay. So we don't treat it as a quotient.
Yeah, we're going to come there. And then we over.
Okay.
Exactly. Function. What is the function? This, which is x. Do you agree with me?
Yes.
That's what I did here. So now, this is a quotient rule. It's easy. So you see, you are already identified as a quotient, but you need to remember this, okay?
Yes, that you must deal with it as a ln first.
Of course, yes. So if you don't know the rules, you see it's tough. Like if somebody, that's what the first day, I think it was Simbu, she said, but that one is understand, but I want to go to the textbook or study guide, it's tough.
Yeah, you see flames.
She didn't know the rules, you know? So that's just a way for us to learn all the rules. And then now by look, it's all, that's a quotient right there. I know how to solve quotient rule. So we know quotient rule says F over G. Let me see if you can see. Let me do this. F over G derivative equal to denominator constant. I'm trying to remind you a little bit, right? Denominator must be constant.
So now we are dealing with it as a quotient, correct?
Because it's quotient. It just came by coincidence. We didn't know it was going to be quotient.
Yes.
That's why you have to use
so so your second function becomes constant,
which is G constant.
Yes, and then you differentiate your f constant.
Yeah. And then here we're going to say.
And then you minus. And then your f is constant, your g you differentiate. Over g squared.
So we're going to do the same thing here. So then we're going to say that stuff right there, which is that, which is dx of x plus 5 equal denominator constant. What is our denominator?
The denominator is square root of x plus 5.
Okay. If you cannot see, I can change the pen. Denominator is square root of x plus 5. And then we're going to differentiate the numerator. Let me do this. Do you agree with me?
Yes.
Because you want to save the time sometimes. And then what we do then?
Minus.
And then we minus.
And then your f is constant. So your x is constant, yes. And then you differentiate x plus 5. Square root of x plus 5.
And then we over.
Then you divide all that by square root. Squared.
We're gonna simplify, get something smaller, and then we're gonna come and plug in here.
Okay.
Now we go now. When you differentiate x, what do we get? 1.
1, yes.
Okay, so now look, right? Okay, equal, this is going to be 1. So here we're going to be left with, let me do this. Let me start from the left more. So when you differentiate, this is going to be 1. So here it's going to be x plus 5 squared. Minus, minus. X is just x. But when you differentiate this, you do it aside. You don't have to do it here because you're going to write it later. So, okay, but okay. When I differentiate x plus 5, I cannot differentiate like that. This must be x plus 5 a half. Let's do that. Do you agree with me? Because we cannot differentiate when it's in the root. We have to put it.
Yes, correct.
After that, we say, well, you see, this is my differentiation. Yeah? Let's differentiate. So when I differentiate, what happens? This half is going to go to the back.
To the front.
It will become a half
X
bracket, drop the how it is, x plus 5. Take the power minus 1.
Yes.
So a half minus 1 equal to negative.
Negative half.
Okay, and then we differentiate what is in here inside the bracket. Do you remember that?
Oh, wait. So you deal with it as 1.
Yes.
Okay, so you don't do like x and 5. You treat it as 1.
You drop it, boom.
Okay.
Remember, whenever you have a bracket, you choose the 1 thing. And then after, we're going to differentiate what we have here. When you differentiate x, you get 1. When you differentiate 5, you get what? 0. So this is like a 1. Listen. These are the first things we did when the first days moving together. If somebody did
no, I understand. But then what happens to the half?
3x. No, we have the things there. Let's say this is the same thing. This has nothing to do with this question. What happened here? I'm going to take 3 at the back. We drop everything in the bracket. 3 minus 1 equals 2. And then after, differentiate what you have here. When you differentiate x squared, you're going to get what? 2x. But if you differentiate, there's a plus, there's a plus. When you differentiate 3x, you get 3. And that's the final answer. So now we come here. Did you understand this?
Yes, I did.
So now let's go back to our problem. So what we say here, let me read it so you can see again clear. A half is going to go to the back, it's going to be a half bracket because you differentiate.
Yes.
We drop it. Now you talk to me, tell me now so you can see if you understand what we do there.
X plus 5.
So we drop it x plus 5.
And then to the power negative a half.
Yes, because we take whatever we have here, minus 1. A half minus 1 equals to negative 1. And then after?
Negative. And then after that, so you differentiate whatever is on the inside.
Yes. So whatever is in here, inside the bracket, we differentiate, they will write the answer here. When you differentiate x, what do you get?
1.
You get 1. And then plus. When you differentiate 5,
Plus
what do you get?
0.
So 0 plus 1 is just a?
Is 1.
1. But anything times 1, like if somebody say 4 times 1, you just say 4. Means x squared plus 5 and negative 1 times 1 is just that. So I don't need this one here.
So we have a half.
So now we cannot live like that. Remember, we must say this equal to. Remember, it's like this. So remember, whenever we have a negative power, we don't want to live like that. We must reciprocate. Yes. So this is going to go to the bottom. So it's going to be 1 over 2, and then 1 over 2. Okay. Bracket x plus 5 power a half. Because all this, it went to the bottom. So it's 1 on top. This one to the bottom means it's with the 2 in here. With the 2 x plus 5 plus a half.
Okay. So what happened to that one that we were calculating?
Which one? Here.
When we were differentiating in the middle, the x plus 5.
The problem is we were stuck here, so we need to work it out with this stuff.
Okay.
You understand? So when you differentiate this, and then it's going to become better. In other way, if you remove a half, you can put square.
Yes.
So when you differentiate, you have to get this. Now, let me show you a shortcut. You don't have to waste a lot of time like that. There's a shortcut you can do. If somebody gives you one, but this only for square root. If somebody gives you it,
this looks easy, but it's complicated.
No, it's very easy. Let me show you the easy way you can do, right? The easy way.
Please.
I'll give you differentiate. You know we're gonna have a half at the back because it's gonna be x power half. So what you do, write 1/2, and then write this stuff at the bottom, and it's done.
Yes. You're correct.
Okay. If this is 2, let's say there's a 2 here. Let's say 3. When you get this, make sure you differentiate what is in here, which is going to give you 3x squared. You're done. Because this one is with no x.
Oh, yes. Okay, I understand what you mean.
So if it's, let's say, 5, means when you finish differentiating, you must differentiate what you have in from what? 5x plus 4. So this is going to save a lot of your time. So if, for example, they give me that, so what that means, this stuff here, is let's say, now you tell me now how it's going to become. It's always 1/2, and then square for whatever you have. How is this going to become? 1/.
It's going to be 1/2.
1/2.
X plus 5.
Yes, square root of example.
Square root, sorry. Yes.
You understand?
Total sense.
Okay. Now let me challenge. How you?
Ah.
No, come on. Here, it's very, very important. Right? How it looks.
True.
How it? Because you don't want to solve and solve. Sometimes there's a lot of shortcuts in it. How will somebody give you? Differentiate. Now give me the answer. So how are you gonna say it? Same tactic.
Yes. 3. No. 1/2.
1/2.
And then open your square roots.
You write exactly. Yes.
And then you're gonna have 3x squared plus 4.
And then?
Oh, you're right. I already gave you the answer. Sorry. And then after that, it's gonna be 1/2. When you, yes, I'm not differentiating the brackets.
Okay. You see after this,
There's
right?
Gonna be 3x.
Okay. 3x
squared plus 4.
Come on, this is easy. So you don't want to waste a lot of time, right? But addition does not work for cube, only for square. 1/2. Okay, so the easy way, right? You do this, right? Say this. There you go. Easy. You don't even have to waste your time now. Tell me how this is going to come now if you differentiate that. So this is going to be 1 minus x minus x. And this how it's going to become? Give me the answer.
1/2.
1/2. You see how I write my number? Top, bottom.
Yes.
1/2.
Yes. And then square root of x plus 5.
We don't want to write anything here because you know it's going to be 1 and 0, so just 1. It's easy. Is that hard?
No.
It's not hard. So after that, remember we have a division, and then I got that. This and this is going to cancel. So it's going to be x plus 5. You agree with me? No, I'm wrong. I'm wrong.
Oh, yeah.
Means you don't have no root. I'm sorry.
So I almost said
It's one that like
it's gonna be x plus 25. No?
Because this and that cancel.
Oh wait, the brackets and the 2 cancel. They don't cancel the.
If somebody gives you what? Y square, what happens? This and this cancel.
Yes.
That's all. So this cancel, so that's x plus 5.
Okay.
Now,
Yes.
Here you have an x times 1 over 2. So you can simply say x on top. X times 1 is just x. So you can say here x.
Yes.
And I can put this over 1 because we want to be in a good form. You're looking.
Yes.
So we want to find the common denominator here.
X plus 5.
Look here, right? Look, listen. This is normal fraction. If somebody gives you A minus C, D, you can work it out this. It's just like that. They give you something with something. I'm going to say this is over 1. And then normal fraction, what do? You cross and you cross. A times B, A, D. 1 times C, just a C. Minus, over, you multiply this 2. 1 times B, just a 2. That's all. Let me say it again. Should I say again?
Please.
All right, no problem. Fraction.
No, that part I understand. I want to see how it applies to the sum, to the function that we are working with.
Okay, now tell me, how are you going to cross? Because this is like a fraction. Top, bottom.
Don't you leave it like that?
No, listen. You did not understand me here. I feel like you didn't understand. Look here, right?
So I'm supposed to
minus AC. Simplify. How are you going to simplify? Say this over 1.
Okay.
It's the same thing. Don't look how it looks. You see like how it did here. You say, okay, I'm not look at the content. I just follow the rules. So this is a fraction. How I'm going to do? I'm going to cross. T times C. Whatever is in here times this. Minus 1.
So in this case, it's going to be that x plus 5 times
that.
Times square root of x plus 5 over 1.
Okay, cool. Fantastic. So don't look at the content sometimes. All you need to follow is the rules. Math is the rules. The only time you start confused, it's like, oh, what is this now? My God. There's a root now. I got negative number. I think it's wrong because I get negative number. It's not wrong. It's right. So this is equal. Here, let me ask something. If somebody gives you square root of 3 times square root of 3, what do you get? You know what you will get? Plug in the calculator. Oh, you don't have your calculator with you?
No, it's here. Isn't it 9? But okay, let me just do it.
No problem.
Oh, two square roots.
I give you square root of 3 times square root of 3. What do you get? No. You didn't plug correct. Look at this. Look at this, right? Can you see?
Did you say plus or times?
Times. Same thing, times.
Oh, sorry.
Square times 7 squared. Times. When you write that means times.
Oh, sorry. I said plus. It's 3.
So whenever you have a root, multiply by the other root of the same content to give you the same thing. So if somebody give you y squared times square root of y, what are we going to get?
Y.
Wow. So now if I take these two multiply, what happens? This and that is going to be x plus 5, no roots,
Yes.
times 2, because there's a 2 here.
Yes, yes.
So it's going to be
So it's
2
gonna be
bracket x plus 5.
yes.
So we're going to say then,
Sure, this one is a lot.
no, it's not hard. Like the way how they give is like, all you need to follow the rules and patient, that's all. So we're going to say, well, so this is going to become, all on top, this and this is going to become 2 x plus 5. Minus, minus. Here is just it. 1 times x, x. The over 1 times this. Are you think?
Yes, yes, yes. And then it's gonna be
But process your rules. Don't look how it looks. Remember your rules. Just follow your rules and you'll be okay. So 1 times is going to be what? 2 square root of x plus 5. And then you write your bracket, this is the top one, and then we over x plus 5.
that time we are still working on the first part of the equation.
Eh?
Sure.
Now let me answer this. We finish already. We finish. So what happened? Look here. If somebody give you this is okay. This is like a fraction. You're looking like a over b. So if somebody gives you, let's say a over b, and then all of this over another group, which let's call it c. Then let's take a number. Let's take a number, for example. If somebody gives you 2 over 7 over 3. In math, this 3 is going to come here at the bottom.
It's gonna come to the 7.
Yes. If you have a fraction of a number, fraction, because here's like a fraction over something.
Yes.
Like I said, do not look at the content, right? Look at the fraction. Put your head like a over b over c.
Okay. So if it's a over b to the power, I mean over c, it means that b and c become 1.
So it's going to be a over b, c.
Let me just write that down. Hold on. A over b over c.
But you must put the bracket on top because this is the one group.
Yes, yes. Equals to a over b c. I'm with you, sir.
No problem, madam. No problem, madam. Okay, so we're going to say now, this, where is this going to go?
It's going to go to b. So it's going to be 2x square root of x plus 5 times x plus 5.
Yes, thank you. So then, I want to see if you can see everything here. Let me do this.
No, I can see clearly.
Okay, I want to write something the next line. So then we're going to say now, so it's going to become, you see, it's going to become, this top is going to, okay, on top is going to be, let's simplify on top. It's going to be 2x plus 10.
2x plus 5.
Plus 10. 2x plus 10.
Oh, you worked it out.
Yes. Over, this monster here is going to come here. So it's going to become 2x plus 5. And the square root, x plus 5. What is 2x minus x?
X.
X. So then finally, it's going to be x plus 10 over 2 x plus 5 x plus 5. It is going to be a final answer. Now let's check in our page and see.
That's the answer.
No, but it's not the same. That's the crazy thing. I made a mistake somewhere because it's not. You know what? Let me show you why I made a mistake. Let me show you why I made a mistake. Let me show where I made a mistake.
Why did I think? This one is showing me flames.
No, it's easy. Let me show you why I made a mistake. You see here, right? This and this, it give us 2x plus 5. This and this, give us that. And then we over
When did we work out the bottom part?
So again?
When did we work out? Remember, it's a quotient.
Yeah, there's something I forgot here. There's something I forgot. What I forgot. Let's say together, right? Let's say so you can see also how I'm making it stand. So you can learn from yourself. Look. Here we say, oh, you're right. I'm sorry. We need to come and plug everything in here.
Yes. First, and then do the bottom.
You know what?
And then.
Yeah. This is what I like to work with you. Because you simplify my words. I just forgot, like, where is this now? Thank you so much. Yeah. So all this stuff.
So we only did the top. We still need to do the bottom.
This is the top. So I'm gonna erase everything and plug in there. Thank you so much. You see, I was such a thing like, what else is
I'm gonna have to practice this one a few times to fully get it, like fully.
But you understand the hang of what I'm doing, right? No, you understand. Because now you actually correct me, you know? So I'm gonna raise some stuff. Okay, we don't need all this.
Yeah, this one is a lot. But it's okay. You know, I like to panic. I always panic because I like to do things right. So I'm already thinking, like, if I was in a test, I was gonna be panicking. I was writing accounting this morning, and I panicked. Went into total panic when that time started to run. You know,
Is it exam or is it assignment or test?
It's assignment 3. So it's type. No, it's assignment 2. What am I saying? It's assignment 2. And I just panicked. Immediately it opened, I was just like, oh my God. So I always panic. That's my problem.
Fine. Just calm yourself.
I need to. Like, if I saw this in the exam, I was probably gonna be like. But it's fine. Let's do what we're supposed to do.
Yes. Which accounting are you doing? Is FSC which one?
Yeah, it's financial accounting.
Okay.
I think I didn't practice enough because I have a lot on my schedule, and I'm just now like, whatever I get, I'll accept the bare minimum.
All right. Okay, cool. Now, thank you so much for actually remind me. So we take all this stuff here, right? And
then it goes to the top. Yes.
Equal. So this is going to be x plus 10. And then the bottom is 2. X plus 5. Square root of x plus 5. And then all this stuff, we over x.
But we can just rewrite it, and then we can put it to the power of 2, correct? Is that no?
We just take this stuff and then we come and replace this stuff with. That's what I did here.
Yes. No, I'm saying for the bottom part, because the same steps are going to be applied. We can just take that sum and put it at the bottom, and then you square it.
No. Look, the bottom one, no differentiation. It's just a function. Remember in a loan, we said loan.
Oh, we don't differentiate. You're right.
F prime over f of x. So this is f of x. Talk to me. When you differentiate.
I understand.
Yes.
But when we. Hold on.
No, so talk to me, I'm listening.
Yeah.
F prime over f of x. F prime over f of x.
No, I thought we were going to treat it like the lawn, but no.
Look.
What am I saying?
Look.
No.
The question was lawn of 14 in 20. But when you differentiate long, look, you differentiate your function.
Yes, it's fine. Yes.
Over
So you
x.
write it like that to the power 2.
So this is just f of x. But here, look.
Squared.
This and this is going to cancel. Do you agree with me?
But don't you square it first?
What do you mean square root?
You know, when you do the quotient rule.
Listen here, you confuse things, right?
Am I confused?
No, let me say slowly. Listen. When you differentiate log of a function, how does it say?
You differentiate the function.
What is a function?
And then you write it at the top, and then the bottom you write it exactly like that.
So at the bottom, we write the way how it is. So now, if we go back to the question, I want to rewrite the question so you can see what I mean. Our question was.
Yes, you're right. Sorry.
Do you understand now? Or. Eh?
You're right. Yes, I was thinking too much.
No problem.
Yeah, I was like trying to overanalyze it.
No problem. So, do you understand why I cancel and I cancel, right?
Yes.
So now, what we left with? We left with x plus 10, 2, x plus 5, over x. Where this x is going to go?
It's going to go to the 2x plus 5.
So then we're going to have an x plus 10. It's going to be 2x, x plus 5. Let's check there. In the answer.
Yeah. I see the answer is correct, but I'm not happy.
Should I do it again? Quick now, since you understand?
Yeah, like the entire thing, if you don't mind, please. Like I see, yeah, we got to the answer, yay, but like my brain didn't like fully.
So what I'm gonna do, I'm gonna do it quick now, right? But since you understand the process, right? Okay, cool. Let me just wipe someone. No problem. Don't worry about it. I'll repeat it, okay?
Okay, I'm gonna listen and not write. I'll write after.
Don't write yet. Don't write. Please, just listen to me. Okay, just a second.
Can I just get my charger? Sorry.
No, oh, yes. Okay. Whenever you're ready, let me know. We go. Whenever you're ready.
Yeah, I got my.
You're
Oh no, it's not charging. Sorry. Yes.
Okay. All right. You ready? Hmm?
Yeah, I'm good.
So what are we going to do? We're going to say f prime. When you differentiate 14, what we get? 0.
0.
plus plus. I'll just go straight, right? When you differentiate log of whatever we have, what do we say? Take your function, anything in front of the log of your function, differentiate it. Means I'm going to say this is same as say differentiate whatever I have here, whatever I have in my function, and then we over function with not doing
the function. Yes.
So the problem is in here. We need to take that and do quotient rule, all of it. If you don't understand, let me know. I'm going to keep going, right? If you don't understand, let me know.
No. I understand. So you're saying that whatever is in front, no, the whatever is after the ln, you treat it as a ln, right? So we are only going to deal with the brackets like the quotient because of that's what we have.
Because it
at
just
the top. Okay.
Yes, because it just came by coincidence.
Yes.
Because when you
Okay.
differentiate ln, the function, let's say somebody say differentiate all of this. This same is say, write your f prime, means take whatever is in here, differentiate, and then you over your function. And that's what we did. There's a ln of a function. We take all these functions, we differentiate all these functions, and then we over exactly what is in front of the ln, right? At the bottom.
Okay. Okay.
So then the problem is in here. We need to deal with this only. So if you take the side here, we can say, if I differentiate the x plus 5 quotient, we go to the quotient rule. The quotient rule say, write your denominator constant first. This is my denominator. Constant. If I differentiate x, what do I get?
1.
1. We minus. And then what we do is switch.
We switch, yes.
Will be constant.
Constant.
When we differentiate square root of x plus 5, what do we get?
We get 1 over 2x square root x plus 5.
X plus 5. That's all. And then what do we over
x plus 5.
Square of denominator. So when you square this, it's going to
be
x plus 5.
I'm thinking too much about it. Yeah.
I'm trying to make it like a simple, straight to the point. You understand here? So before we have. So now, don't write anything, right? I want you to listen. So this is 1 times something, just that. I don't have to write 1 because 1 times 4 is just 4. 1 times this is just that. So I can simply say this is over 1. X times 1 is just x.
Yes.
The fraction here, so I must take this multiplied by that and that multiplied by that. So I'm going to say, well, this is going to give me, if I take this times x plus 5 square root times x plus 5 square root, what are we going to get?
We're going to get x plus 5.
It's just x plus 5. So this is going to give us what? X plus 5, but there's a 2 here, so we're going to write the 2 behind. Minus. And then we go 1 times x. Over, you multiply this 2. 1 times this is going to give you 2 square root of x plus 5. But this is for here.
The top.
We need to divide by x plus 5. But I told you, if somebody gives, let's say, t over b over m, where m is going to go?
By the way, the b is going to be,
so
yes.
E, B, M. So this is like T, let's say all this is T and all this is B. So where X,
Yes.
which is M, is going to go?
We are moving it to the B.
It's going to come here. It's going to come here. So then it's going to become, it's going to come at the bottom. But at this you can simplify. 2 times X, 2X. 2 times 5, 10. 2X minus X, simply say X.
X minus.
Plus 10.
Plus 10.
So the over, this thing here is going to come at the bottom. So at the bottom is 2 square root of X plus 5. And then you have what? X plus 5. So this is only differentiation of them. And this is differentiation of them. So we have to take all this stuff here and replace with that. So we're going to say now, so I think this is erase this because I don't need it. All right. So then what we do, we say, well, this will become, instead of that, I have a normal answer, which is going to be X plus 10 plus 10, 2, 2, square root, X plus 5, X plus 5 outside the bracket. But at the denominator, I've got my X plus 5. So what happened here? If somebody did, for example, let's say a T over K M over C over K B, what happened? K and K can cancel.
Yes.
So
they're gonna cancel your X plus 5 square root is gonna cancel the other X plus 5 square root.
We're going to write what we left with. Now, what we left with on top is X plus 10.
X plus 10. And then your X is going to go to the 2.
And then bracket X plus 5.
And then you're going to take that X. We are left with one more X. Oh, yeah.
Now, tell me, where you're going to go?
You're going to use the AB to the part AB, A divided by B divided by C, and then it's going to be A over BC. So your X is going to go to the top where your B is. It's going to be 2X.
Yes, so this is going to come, here it's going to be X plus 10 over 2X. And we ready, huh? Yeah.
I think my mind needs to program. Okay, you stepped out of ln, you are now stepping into quotient, then you are back at ln. I just need to.
So all you need to do, don't memorize because it's changing every time. Sometimes it may come as a product rule. So
yes.
If product rule, then you have to do as a product rule. For example, if it was, so this is a final answer. You understand this is a final answer. If it was, let's say like this. Here. Let's say just example. Let's say it was like X. Then you have to do product rule. X times square root of X.
Wait. This is the ln.
Okay. Let me take an example.
Yeah.
If our question was going to be like, let's say 5 plus ln of X square root of X.
Okay. So it's going to be, you differentiate that.
It's going to be 0, and then you have
0.
to differentiate whatever is in here. Means it have to be differentiate X square root of X over X. So this is the product rule now.
Yes.
So you have to take it aside and deal with it. And
deal with it. And then bring it back into the ln. Okay. Yeah.
Easy.
I think I'm okay.
All right, cool. Let's do another question. You got some energy, or you start to feel
Yeah.
something?
No, this question woke me up.
No,
Yo.
no problem. No problem.
Yeah.
Let me see which question should you do right now. Okay. Okay, the question that you like. Let's do that one. So let's do the second derivative. Okay, so I'm gonna do it in a shortcut way since you understand how we do it. Okay, so I'm doing a
Can
shortcut
you
way.
please just send me a picture of all that mess, but I understand it, the one on the board, please?
You don't want to screen capture because they raise a lot of this. This is
Okay, just hold on. No, I'll screen capture, it's fine.
I can take a picture if you want, no problem.
No, it's already done. Thank you.
Cool.
Don't worry about it.
Here, I want to see you drink some water because now you're gonna get thirsty. You know, you're talking constant. The whole 1 hour is not good. Get some water, please. Get some water. Get some water so you can hydrate. All right. So drink some, so you can get some energy. Okay? So you can get some energy. Ah, okay.
Are you happy?
I'm happy. Now, so at least you're hydrated. Now we go. Let's do that question now. The one for second derivative. Let me wipe these boards so well. Because we're about to do the second derivative. I want to buy some land, you know, like some land and start a bigger project very soon. Okay.
Right, okay.
All right. Let's do that question. So I'm not gonna do like writing because okay, you see this your take your exam is gonna be multiple choice. Your exam, you know. So I'm gonna do
Yeah,
the short.
apparently it's like 30 questions.
So I wanna do shortcut one. The assignment 1 and 3 is way easy. Like you just do question one, so we move. Not like this. This you have to practice a lot. Okay.
What's this? This is
Differentiation.
no, I said you said assignment 1 to 3 is easy.
Yeah, 1 and 3 is way easy because it's like financial math. You're plugging.
This is not like financial maths.
No, I'm just, that's why I started with this because this one is not like for students who have not done math or calculus. For them, it's
Calculus,
hard,
yeah.
but it's not hard for me. You know?
Calculus is a lot. I think the annoying thing about calculus is the little bits of things you can't ignore.
Yeah, you
Because
can.
then you're not gonna make it.
So. All right, cool. Now innovate. Oh, God, it's they give us here f of x equal to can I please respond to one of the students here? I think he's a new student. He's asking for some stuff. You
No
know,
problem.
last minute students always ask like, oh, my stuff is due tomorrow. Please.
Oh, shame. Okay.
Sorry about that.
Hmm. Hi, Shem.
Yeah, the new student asked, oh, please, I saw your video. I want you to help for some, for some water.
Sure.
Okay, so now let's say find the, oh my God.
The rough. Are we doing that one again?
Yeah, the same question. Sorry about that. Let me tell this patient so that you don't want to cause me.
No, please don't worry about it. It's okay.
All right, cool. Now let's go. So the question says, it's very bad. Some people don't know how to do business. They scam people. They some in the social media. It's like, how you gonna do business by scamming people? Like, let's say
You make money out of it.
200 or 150 or 300. You cannot live with it. Now you're gonna be hiding and hiding, but your days are numbered.
No, you can't do that to people.
You say it. You just say it.
You really cannot, like, and people really need help. Like, you can't do that. It's so sad.
All right, let's go. So we have the E power X over X. So let's say find the second derivative. If you can look on top of the question, they say what? Find the second derivative. Second derivative. Second derivative means derivative first time and then do the second time. Now let's go. So now we're gonna say this derivative right now. So here, tell me right now, which one is this? Is the product rule or quotient rule?
It's the quotient rule.
Is the quotient rule. So according to the quotient rule, we're gonna say f prime or face derivative face derivative equal. Let's do straight away. Like
You got also with the equation, right?
yes.
So
we do straight. Or you want okay. I think we can
no, we don't have to write it down. So your x is going to be constant.
So denominator is going to be constant, which is x.
Yes, and then you differentiate your ex.
So we differentiate e of x. So when you differentiate e of x, what do we get?
One.
What?
And then ex. Yes, one ex.
Yeah. It's just an ex. So it's going to be the same thing, ex. Yes. Yes. And then?
And then you minus.
And then you minus. Very good.
Your ex is constant.
And then ex is going to be constant.
And then you differentiate your x, which is 1.
1. So it's going to be just ex times 1 equal to e of x. And then we over
x squared.
We take the denominator and then we square, which is going to give us what? X squared. So this you can write as we can do something about it.
You can take out the denominator, the common factor, which is e of x.
Ex. If you take it, because there's an ex and there's an ex, you take it out, and what's going to be left in the left?
1 over 1 minus x.
What?
X minus 1. X minus 1.
And then we over what? X squared. But this is a first derivative.
Sorry?
This is the first derivative.
Yes, this is the first derivative, yes.
You have to do it again, second derivative.
So now we have to do the same thing, but now to the new function that we have.
Yes. So we need to take this one right here and do. So you have to look. What is this? This is a quotient.
Yes.
Now we go.
So your x squared is going to be constant.
So denominator is going to be constant, and then we differentiate.
And then
so now we cannot do one for because it's kind of folded, you know. So we're going to say differentiate the numerator.
Okay.
Which is ex bracket x
minus 1.
And then what we write here?
And then minus.
The minus. And then?
Your ex plus 1, x minus 1, sorry, is constant.
The constant, and then now we're going to differentiate.
And then you differentiate your x squared.
Which is going to be 2x.
Yes.
But a 2x, I'd rather write before everything, you know? 2x. That's a good way, you know? Let me write big a little bit. That one is not too big. Let me see, 2
over.
Thank you. Over.
X. Is it cubed? No. What is it? X to the power 4 is going to be x to the power 4.
All right. So what is the problem here? If you can look where the problem is, we need to do some here. Here. Look here. The problem is only here.
Yes.
So let's take it aside. We don't want to do everything right over. Let's take it aside. When you finish, you're going to come and plug it back. What do you think? Please and deal with it here because D.
Oh yes, I was trying to solve it. Sorry, yes, we can do that.
Okay, so we don't want to write there's going to be too messy, okay? So say let's take this one here and say when you differentiate the x minus 1. Now, what type of differentiation is this?
Product rule.
Product rule. So how are you going to say again?
So your first is going to be constant. Your second constant. The x minus 1 is going to be constant.
And then we differentiate ex. When you differentiate ex, we get ex. Exactly.
You get ex, yes.
Yeah. And then which sign is going to be here?
And then plus.
It's going to be plus because the product rule from the previous section, right? And
yes.
And then we plus
your ex is constant.
Ex is going to be constant now. Means we put this constant, we differentiate ex, we get ex. We plus. Now ex is constant, and then we differentiate x minus 1. When you differentiate x minus 1, what do you get?
We get 1.
It's just a 1. So 1 times e times x is just it?
Yes.
And then we note, are we over something or we don't?
No, I'm following.
So we don't write over anything because it's not quotient.
Yes, it's not quotient. We are just dealing with that part so that we can take it back to the equation.
So what I want to do, I'm going to take all this stuff and plug it in here.
Yes.
Or if you don't want to do that, you can say, well, there's an ex. Let me take it out. You know, it's always good to simplify things. You don't want to plug in there. Okay. And then if you take ex out, ex going to go x minus 1 plus, because look, this went out and this went out. So the x minus 1 here is going to plus or plus 1.
So it's ex.
Yes.
Only ex and then x.
Oh.
Yes.
So it's going to be x. Yeah. Oh my God. All this stuff just give us xex. If I knew I was going to do so, I would say xex.
Can I please screen grab that first?
Okay, no problem. You can do that. You know, something I learned about you here. It seems like you like math. Even though it can be challenged, but there's some you kind of develop interest in it.
I do like maths only when I understand it. If I don't, then I don't mess with it. Like it can stay away from me if I don't understand it.
I see. So I'm gonna replace that. So we're gonna erase this stuff, but I'll show you a way. Like if it's a written, let's say you're doing some stuff, make sure you show it. But if it's multiple choice you want to run and solve, you don't have to show everything. So
yes.
e power x. So all this stuff here, I'm going to say x equal x. So all this stuff is just x equal x. And here we have x squared. X squared, I'll write closer to it. And this one will erase. All right. So now let's see if we can factor something out. X, x. E power x, e power x. We can take it out.
So we can take out x, ex.
X, ex. If you take x, ex, what I have left it here?
X squared.
X squared. Or x
Wait, no, x. Huh?
X e power x is down. So just x squared.
Okay, yes.
Minus, minus. X e power x went out, so we left you there 2 x minus 1. Then over x power 4. Okay, now 1x go and 1x go. So here, no more x, and here is going to be 3x. So we go first in our memo and we see if the memo is like this, or we can simplify in. Or we can say, okay,
so can you simplify and say 2x minus 2?
Of course, yes. 2x plus 2. So you're going to say x squared minus 2x.
Oh, plus 2.
Plus 2.
Yes.
And then over x cubed. So here it's going to become, let's rewrite. When we finish, we rewrite. I can write on top here because we finish everything.
Which one was this one? I want to see the answer.
Oh, you want to take the answer?
Yeah, but my laptop is doing miracles.
No problem. I'm going to check here. EX.
Okay, it's frozen.
And bracket, x squared minus 2x plus 2 over.
How?
Over x cubed. All right, let me check here. Yes, we got it. God.
Did we get it? What is this laptop doing?
No, we got it. Got it. Got it.
Which one is the screenshot? Why can't I find it anymore? Okay, let me just write it down. I'll go. These are just too many. So the second derivative, the answer is.
In your phone, you're gonna see. Oh, you wanna check exactly. I see what you mean.
Math is crazy to think that if there was a something like a third derivative, you can still work that thing out.
Yes. Math is fun.
Yeah, no, calculus is the piece. It's the piece. It's the piece.
Should I send you another question? Oh, you tired? There's another one. Last
No,
one.
we can go. We can continue.
Let me send you this. Let's do this one. This is the last one.
Okay.
Let me clean my whiteboard so well. The loan. They like to give loan question, you know?
Yeah, because loan can throw you off if you're not thinking.
Yeah. Oh man, math to confuse a lot of things. Because the problem is people don't want to follow the rules, and that's why it gets hard. Because the moment you don't follow the rules, if it's not conscious, oh, what I'm gonna do here? Ah, I don't want to do this. I'm gonna do next thing. He say stop.
True.
Because people don't want to follow the rules, and it get hard, you know.
It does. Yo, they better change the exam. I can't write the exam on the 18th. No, that's madness.
That was gonna change.
You're like, they've changed the date so many times that, like, assignment dates. No, we can't write the exam that.
Yeah, I don't think it's too early. That's what I feel.
June is fine. June is fine. June is fine. I need that one more month. I need it.
So think about what I told you about economics. You know, it's a lot of people.
And I'm actually going to be busy with it now because I have to write a test. Hopefully, I'll write the test by 4 in the morning. I'm just going to have to go through my work again and then write the test because it's a timed one. It's like an hour and I have to go through like a few chapters, but it's just revision. Yeah.
Those are things that we all right. Let's do some questions here. So this is P function means Q of x equal to long bracket 4x plus 1 cube 2x minus 5 power 4. That's a question. From the same
4x plus 1
cube plus 3. And then, should I write big a little because this is too small?
No, I got it.
Okay. So let's say, wake it up out. Let me get some pins. Let's put some new marker pen. I don't know all this. So what I'm gonna do, the rules are the same. Now, work with me. I don't say you must do everything like, but just by starting. So what do you notice? So how are you gonna start?
So first of all, when you deal with loan, you know that your entire function, you're gonna, what's the word? Hold on. You're gonna differentiate the entire function and then you're gonna divide it by the way it is.
Okay, cool. Then we know. So this is gonna become P prime easy derivative equal. We take the entire function.
Yes.
All of this stuff. You know, these people like they're full of time wasting. They just wanna waste your time. That's the intention. And then after function, but we must differentiate. So we can
differentiate.
Should I put dash or should I say derivative?
Anything works with me.
Okay, cool. We derivative dx. And then we over exactly. You don't want to listen or you want to try what we do? No problem. See what's better for you. All right. So now we're gonna. Oh, what we're gonna do then?
And then after that, we're gonna take the top part of the function, and then we're gonna deal with it as.
Okay, cool. There's a quotient rule. There's a quotient.
Yes.
So this is a quotient on top is gonna be denominator constant. Oh, my pen, yeah, it's big right now. Okay, denominator constant 2x minus 5 power 4 constant. And
And then you differentiate the
Then-
4x plus 1.
Now, give me the answer straight away. I'm not going to say ddx. Let's differentiate straight away.
12.
No, no. How 12?
It's going to be you. I think. Yes, I'm right.
Behind here, 3 times 1, not 12.
Oh, yes. I forgot. I was treating it separately. Sorry. So it's going to be 3.
So we're going to take this number 3 times
Yes.
1,
Yes.
3,
So
and
3, open your bracket, 4x.
we drop the how it is, to be 4x plus 1.
Yes.
Because we're going to take 3 times 1. Okay, let me do slowly, right? So denominator, because we differentiate this one, denominator constant, we write constant. 4. We differentiate that. So how we differentiate that? It's like, look, 4x plus 1, power 3. 3 times 1, 3. We drop this, it's going to be 4x plus 1. 3 minus 1 equals to 2. And then we differentiate the inside, which is going to give us what? 4. 3 times 4, 12. 12, 4x plus 1 squared. So this will be 12. So I can simplify here 12. Yeah? 3 times 4. 3 times 1 equals 3. We drop it. 3 minus 1 equals 2. But you must differentiate what is in here.
I agree. So how did we get to 12, then back to 4x plus 1?
4 times 3 equals to 12. Here, if somebody give you, right? If somebody give you 2y times 4, are you going to write like this in math? How are you going to say?
6y.
It's going to be 8y. Because it's going to be 2 times.
Sorry, 8, yes, 8y.
So same here, I got my 3, I got my 4. I'm not going to write like this because it's like a 110.
Okay.
So say 3 times 4 equal to 12, and they'll write exactly power 2.
Also, you solve the, so you drop it down first, and then you solve it in the middle, and then whatever you get, you put it back to normal.
You mean here, right?
Yes.
Yeah, because you say when we differentiate quotient, write your denominator constant, differentiate the numerator. So I took my numerator here, differentiate this upon us. It's going to come here now. Put numerator constant, differentiate numerator, get 12 for x plus 1 power square. Minus, because it's a quotient of minus. So good. Space is not going to be enough. Let me write here. Space is not going to be enough. So I'm going to say, when you differentiate this one, only there, let me write it. Let's differentiate all of that. There we go. So we're going to say now, let me see this side now. So we're going to say now, denominator constant. What is that denominator? 2x minus 5 power 4. So when you differentiate that, we got 12 4x plus 1. Oh, so I kind of blocked the light, my fellows. Okay. I kind of blocked the light here. It's hard. If it's blocking, I can move the other same side.
No, it's okay.
Okay. So when you differentiate that, you get what? 12. 12. Bracket 4x plus 1 square. And then we got minus. So what happened now?
Now, okay.
Numerator is constant.
Yes.
So it's going to be bracket. Let's put another color here so you're not going to confuse. Numerator is constant. What is the numerator? Numerator is 4x plus 1. Numerator power 3. Now let's differentiate the denominator.
Yes.
Let's do straight away. How are we going to get it? We multiply. Okay, let's do step by step because I don't want you to miss.
It's going to be 4. I don't mind.
Bracket.
4 2x.
2x.
Minus 5 to the power 3.
And then
you bring it down. Yes. Oh, and then it's going to be 2. 2.
But 4 times 2 equal to 8.
8. So
it means this is going to be 18. 18.
8, open bracket, 2x plus minus 5, sorry. Minus 5 to the power 3.
See, and then we have
over
2x minus 5 power 8. Because 4 times 2 we square.
Oh, we're still doing quotient. Oh, yes, we're still doing quotient. Yes, and then it's squared.
Yeah, which is going to be 8 because 4 squared equal to 8.
Correct.
And we say, well, that can be easy. Let me see if I have anything common that I can take out. These are same thing.
4.
5 to its minus
4x. No? No.
And
sorry, no.
Right? You have to pay attention to bracket. Okay. So now look, you pay attention to bracket. Never take something from the bracket and take it out. No. These 10 is the same as this 10. But here there are 3, here there are 4. So which is good? So. This is same as that.
Correct.
But this is there are 4, there are 3. Which one are we going to take out? 3 of them or 4 of them?
3.
3 of them. So we're going to say, I want to make sure you can see everything here. It's very easy, but I don't want to write in a way that it's confusing. So now I can factor out something. Like this and stuff from here. So I can factor out something. 2x minus 5 power 3. So if I take 2x minus 5 power, means how many I'm going to be left with it?
1.
1. So I say 2x minus 5.
Minus 5.
Here is gone.
It's cancelled.
Let's go for number. There's a 8 because this 8 is out. 8, there's a 12. Which number is going to go out? 4.
4.
So we're going to take out 4. So let's write 4 before anything.
We can put the 4 before anything. Before the, yes, that one. Yes.
If I take 4 here, we left with what? 3.
3.
And here there's a minus. And if you take 4 here, we left with it 2. This half is gone. And here is gone. It went out and left with it 1. So now we left with this and then.
Yes.
This one and that one we have already sorted them out. We take 3 of them out. Here we left it 1 inside. For number, we take out 4 here. We left it 3. And here you take 4, you left it 2. So now we've gone for.
So we can take 4x plus 1 to the power 2.
Okay. So it's from 4x plus 1 power 2. So here, nothing left. But here, we left it there. 4x plus 1. Now you close the bracket because this was open. But this one here can be simplified. Normal. Because x minus, but you know what I'm saying?
Oh yes, we can simplify it.
Now, let's deal with it. This is going to be what's going to be? 6x minus 15 minus
15,
8x
8x
minus.
minus 2.
Okay, this and this is going to be equal to negative 2x, negative 17. Negative 2x, negative 17. So I'm going to raise that and write negative 2x, negative 17. Negative 2x, negative 17. Negative 2x, negative 17. Negative 2x.
Hey, they mustn't mix ln and coefficient and quotient. Yeah. It's a disaster.
Okay, so this is what we have now. So what we're going to do, we're going to take all this stuff and come, we plug, because we
To
did
the top.
we plug it to the top. So let's come and plug it to the top. So the top is going to be equal to 4. Wait, we did not divide here, forgot.
No, we haven't. Oh, the bottom.
So we're supposed to say over
2x negative 5 minus 5. I said negative.
So we
Yes.
simplify some of them. These are
Yes, we can. They cancel out.
5 of them is going to go here. It's going to be left on there. 5.
5.
Yes. So here on top is going to be 4. Okay, and then say 4x plus 1. All square. And then bracket. Negative 2x minus 17. And then we over 2x minus 5. Bracket, top 5 plus 5. And then this top is here, remember it's on top. To the top. Is on top right now. Okay. So all of this we divide by this.
Yes.
I'm gonna cancel. We divide by 4x plus 1 over 3. 2x minus 5 over 4. Let's see what we can cancel here. 2 of them is gonna go, and this is gonna go. A little by little.
Yes. So we can cancel that.
All of them. Here I'm gonna cancel. It's gonna be
left with 1. Yeah, so you don't have to write it. And then we're gonna cancel 4 of those, and then we're gonna be left with 1 on. Yes.
So now let's wipe it off and write up our almost final answer. So I'll leave it. So what we have right now is on top is 4 on bracket, negative 2x minus 17 over 2x minus 5 minus 5. But this top is over there. Where is it gonna go?
It's gonna go to your B. It makes sense to me like that.
Thank you.
So your C is gonna join your B. Yeah.
It's gonna be 4 negative 2x minus 17 over 2x minus 5 bracket over x plus 1. Let's check here in the form, in the answer. Yay!
Oh, you're checking the answer.
Yay! You got it, yes.
Is that the answer?
Yes. You can check in your computer. Oh,
Oh
yeah.
my god, it's too many pictures. I can't find it.
Yay! You got it. Easy.
Can I just screenshot? I'm gonna do it again. You see the ones with the when you have lawn, then you have like quotient and
No problem. Don't about. Don't look
like
how big it looks. How
there isn't a problem. It's just about like applying
division, the algebra, the way how they give it to you. Yeah.
yeah, it's
No problem.
yeah. But I sort of have like I get it, but I want to do it on my own again, and then I'll confirm with you that like it's stuck in my head.
No problem.
Yeah,
You can repeat even 100 times if you want.
I have to.
Yeah. Do you screen capture?
Sorry?
Do you screen capture? Or should I?
Actually, I don't know if I did. Let me do it again because I'm not sure if I did. My mind is. But I did now. Thanks.
All right. So I think we can stop here. You did that excellent. You did that excellent. And hey, thanks a lot for coming through. Did you feel like you learned?
I always feel like I'm learning.
Okay.
Yeah, so I'm very grateful.